Hello everyone, this is Roy. This video is mainly made for the robots, integrators and bosses in areas heavy industries like shipbuilding, steel structure, construction machinery, and also coal mining equipment areas with robot automation rates often less than 5%. The main topic today is about the welding robots, especially the increasingly popular collaborative welding robots. Are they the key to breaking through the bottlenecks, industry bottlenecks, and how can we identify the real opportunities in this market? First, let's discuss the current landscape. The welding cobot market, welding robot market, automation market is a mix of challenges and opportunities. Sam's industrial welding robot entered China in 1996. By 2030, certain traditional sectors had indeed become saturated, and now some of them may be declined. However, the whole market is undergoing a dramatic structural changes. Demands for intelligence and flexibility are explosion. Let's look at some key data. In 2024, the welding robot market size is about in China is about 900 million yuan. By 2025, this figure is expected to grow to 1.2 billion yuan by 2030, and this figure is projected to rise to 4.7 billion yuan, with a compound annual growth rate of over 30%. Market penetration is also set to rise rapidly from 8% in 2024 to 35% by 2030. You will want to know where is the growth coming from. It stems from the deep waters, areas with extremely low automation rates. According to industry plans in China, the welding penetration sectors like automation, auto parts, and the furniture industry is targeted to rise 60% by 2025. However, heavy industries such as shipbuilding, construction machinery, and coal mining equipment, steel structures, which account for 70% of the welding volume, primarily involve medium to zinc plate welding and have very low automation rates. For example, less than 5% in shipbuilding. This is the biggest blue ocean. Why is automation difficult in these areas? Large workpieces and complex process are part of the reason. But the most fundamental urgent driver is a structural shortage of skilled labor. Statistics indicate that by 2025, China is going to face a shortage of skilled welders of over 300 million, and only about 5% of them are highly being skilled professionals. Young people are reluctant to enter this field. Experienced workers are gradually retiring. So difficulty in recruitment and high labor costs are no longer just twins, but a survival reality for all factories. Therefore, what factories need is not simply machines replacing humans, but complete solutions that can understand the complex scenarios and enable human-robot collaboration offers a cost-to-performance ratio. To address these demands, let's compare several mainstream technological approaches. The first one, manual welding. Flexible but inefficient with unstable quality, and also now face recruitment challenges. Welding tractors, the small cart, low cost, and can increase speed by 50% to 100%. Anyway, it's limited to straight knives or simple tracks, and of course, poor flexibility. Traditional welding robots, it is stable, high precision, and efficient, but it is complex to deploy and require safety fences and the difficulty in programming, and also involve high investment. And also the collaborative welding robot, easy deploy, easy programming, capable of human-robot collaboration, and highly flexible. Now, maybe the payload is a little smaller compared with traditional robots, but this problem will be solved very soon. So clearly, the value of collaborative welding robot lies in the filling the gap between traditional welding robots and purely manual labor. They require no safety fences and can be programmed while dragged to kitchen. Auger, where an auger can guide the robot through the welding paths, complete programming in just a few minutes with deployment and operation on the same day. And after some basic training, a single auger can operate 2 to 3 devices simultaneously, completely alleviating the dual pressures from the highly skilled workers and high labor costs. Now, having understood the pain points, let's talk about the let's examine the key technologies enabling those robots to break through. Here is a list of technologies. Remember, it's not just simple parameters, but the key help you understand how those robots to solve real problems. These technologies directly address the pressures, the most pressing demands from factories: reliability, simplicity, and intelligence. We can look at this from 3 levels. First level, the nervous system, high-speed communication protocols. This is the most fundamental reliability. Bosses know, in workshops filled with electromagnetic interference. This requires robot or cobots must have communication that must be real-time, stable, and error-free. So 2 key protocols are critical. One is communication between the cobot body and the controller system. Leading solutions use Ethercat. Ethercat, the communication intervals often less than 1 millisecond, ensuring instant command delivery, while many other brands use CAN communication, whose communication intervals exceeding 30 milliseconds. This will lead to pocket loss and delays. And in welding, if you know welding, delays in welding means accident. Second communication is the welding machine and the control system. Digital communication is essential for stable and accurate welding parameters, but many in the market still rely on the outdated analog communication, which can lead to parameter inaccuracies and slow response. Second level, motion capabilities, joint performance, and design. We can look at this from three key aspects. One, smooth drag, job, and precisely braking. A worker can easily teach the robot by hand, like training a student, completely eliminating the programming barriers. 2. Lightweight design. The cobalt body light enough for one person to move. This allowing flexible switching between different workstations to accommodate small batch, multi-variant product. 3. Plus minus 360 degrees joint freedom. This isn't just for the posture, welding postures, adjusting the welding postures, but also imposes high demands on internal cables. These cables must be bend resistant and durable. Third level, the process brain. Intelligent software packages. Actually, this is the core of the intelligence, essentially embedding the experience of master welders into those cobots. 1. Arc tracking. Automatically adjust the welding seam position to handle assembly errors. 2. Multi-layer, multi-pass welding. Automatically clamps the welding pass for sink places, replacing the complex expertise experienced workers. Wire seam fending automatically locates the welding seam, saving alignment time. And the breakpoint resumption accurately returns to the interruption point after unexpected stop, minimizing waste. Additionally, features like laser tracking, finite welding, intermittent welding, and connect positioners, 1x positioners, 2x positioners, and even 3x positioners. These software packages digitize and replicate process, making high-quality welding less reliant on individual skill. Thus, it is a combination of stable, high-speed communication system and a flexible and responsive body and an expert naval brain that transforms collaborative welding robot from mere machines into genuinely productivity partners and capable of solving complex problems. Currently, such kind of cobots are widely used in industries like shipbuilding, steel structure, coal mining equipment, construction machinery, where that it is truly diving into the deep waters. Their position is quite clear: high quality and medium price. They are not cheap substitutes, but redefine standards with high configuration and reasonable pricing, directly addressing the labor and the efficient challenges in medium to sink plate welding. Finally, let's talk about the vision. We aim to genuinely advance the automation of the welding industry through the widespread adoption of collaborative robot technologies. So in summary, from identifying pain points to technological breakthroughs and finally product implementation, collaborative robots are forming a complete closed loop. They represent a more flexible, intelligent, and human-centric future for automation. When robots are no longer expensive devices locked behind fences, but collaborative partners that they can be moved to workstations and work alongside with humans, then the robot automation, the revolution in the welding automation will be truly on the main course. So bosses in heavy industries, shipbuilding, steel structures, and also the robot integrators who have robot automation business. If you want to know more about collaborative welding robots from China, contact me. This is Roy. Thanks very much.